My name is Magda, and I work as a mobile tech leader and Scrum Master at Roweb. A few words about the company. We are a software development company with clients from different areas of the world, and also we have a united team of more than 100 people. We are very proud to have long-term partnerships with a great number of clients. And also, we are happy to have about 90% of our colleagues have joined the company since college. My presentation will try to give you some interesting insights about Room, an SQLite object mapping library. Okay, please try to find an answer for the next question. If you will have the possibility to change something in the Android development, what will it be that thing? Do you have something in mind? Okay. Any other ideas? Okay, so I was also thinking about changing the way to handle the life cycle of the UI components, or even the way to handle the updates on the UI when something is changed also in the database, or even the way to handle an SQLite database in the Android development. If you take a closer look, Google also addressed this same question to the Android developer, and they got also an interesting answer from them. One of the developers said that he doesn't want to deal with the technical things. What do you mean by that? What technical things? You are a developer? He just said that he just wants to deliver the project. And his explanation was related to the fact that usually we have a lot of tasks to finish, a lot of issues to solve, and we don't have enough time in order to make a detailed research about a specific topic. I don't know if this is a good approach, but this was his opinion. If we take a closer look on the way to handle an SQLite database in the Android development, we will find a lot of resources about SQLite Open Helper. We could extend that class, and in this way we could handle an SQLite database in the Android. In order to do that, we need to define a lot of constants for the database name, database version, the name of the tables, the name of the columns. And after that, we need also to create the tables, insert the data in the tables, and finally get the data from the tables. But let's say that by mistake, we forgot to add a comma, and we try to run the code, but the app will crash. So, what are the main SQLite challenges? We have a lot of boilerplate code. We have SQL queries checked at runtime. We have database operations on the main thread, unmaintainable and untestable code. As an answer to these challenges, at Google I/O in 2017, Google launched architecture components. These are more a set of guidelines that could help us, the developers, to build better apps. At Google I/O this year, architecture components are part of the Android Jetpack. And this thing makes the developers happy again. Okay, let's focus on Room and see what advantages does it have. First of all, why an ORM? Why an object mapping library? There are three main advantages. The first one is related to productivity. When we are using an ORM, we write less code because we just create the models and the tool is responsible to generate the code for us. Also, another advantage is the application design. By using an ORM, we have a good separation of concerns in the code, and also we are somehow forced to use some design patterns and to have a well-structured code. And the third one is related to the application maintainability. Because by using a good ORM tool, we are not so worried about the code generated by it, because it should be well tested. So we just focus on adding new elements in our database schema. The code is more predictable. Also, the developers decided what features should be added in Room. So they decided that they would like to have compile time query verification, because it's easier to know from the beginning what's written incorrectly and if we have issues in our queries. Also, we need to have migration support, because we usually we take care about the user's data. Also, they decided not to have Java Query Builder API. And the explanation was related to the fact that when you use a Java Query Builder API, and let's say you want to get the data from 3 or 4 tables, you write that query, and when you come back to that code after a period of time, you will not understand from the beginning what's happening there. So the code is not so predictable. They want to have SQL completion in Android Studio. And right now, Android Studio helps us to write SQL queries directly in our Java or Kotlin code. And also, we have relationships, because SQLite, it's a relational database. Are you ready to start? Are you tired? I hope you will enjoy it. Okay, first of all, we need to add the dependencies. At this moment, the current version of Room is 1.1.1, and if we are using Android extension, the current version is 2.0. An important thing to mention is that if you want to use Room, you should have as a minimum SDK 14. Okay, after we added the dependencies, we need to focus on the components, and there are three types of components. We have entity, we have the DAOs, data access object, and we have the database. Let's start with the entity. Let's say that we have a company class, and this company class has 3 fields: the company ID, the name, and the picture. And I would like to save only the ID and the name in the database, and the picture should not be saved at this level. So the structure of the table will be like this one. The primary key of the table will be the company ID. If we want to do this using Room, we need to annotate the class with the entity annotation. We could also specify what will be the name of the table in our database. And also for each field, we could specify what name should have as a column in the table. The column info annotation is not required, but if you want to use in Java or Kotlin a name and in the database table a different one, you should use column info annotation. Also, the company ID is the primary key of the table, so we annotate it with the primary key annotation. And because we decided not to save the picture in the table, we annotate it with the ignore annotation. So this is how we look the table. And let's say that we want also to save the date when the company was inserted in the database. Usually for this kind of situations, we use a date type. But do you think it will work in SQLite? Any guess? It will not, because in SQLite we don't have a date type. So we need to find a way to translate the date to a type that is available also in SQLite. So the solution is to use an integer. And in Room, we have a type converter that could help us to make this translation. So we'll have 2 different methods, one that will translate from date to a long, to a timestamp, and the other one that will translate the timestamp to a date. So on the Java or Kotlin side, we will work with date, and on the SQLite side, we will work with an integer. This type converter could be applied to a field, to a data access object class, or to an entity, and also it could be applied at the entire database level. DAO, data access object. We created the entity, so we want to access them. We want to get the data from the tables, or to update it or insert it. In order to, let's say, in the case when we want to get the data from our company table, in SQL we will write something select all from company. It's possible to do this thing in Android Studio, and we define this interface, which is annotated with the DAO annotation. and inside of it we define our methods that we want to use for our entity. Let's say that by mistake, instead of company, we will write companies. At this moment, we will get a compilation error, and will let us know that the companies table doesn't exist in our database. Another example of a scenario is to use a DAO for a department. So we have an insert all method, and since it's an interface, someone should provide the implementation for us. In this case, Room will generate the implementation for us. So behind the scenes, Room will generate a class that will implement our interface. And for this department DAO case, we will, inside of it, we'll find a reference to the database and also the insert all method. Inside of the insert all method, we have a transaction. We start it, we insert the data in the table, we make the transaction successfully, and after that we end it. Database. Database combines the entities and the DAOs. And we need to create an abstract class that should be annotated with the database annotation. And inside of it, we need to define the entities. In this case, I define it only the company one, but if we have many, we could add them using a comma. Also, it's very important to add the version number of the database because we could use it after that on the migration. This abstract class will extend the Room database, and inside of it, we will need also to have some references to our DAO, so we'll have some abstract methods. To get an instance of our database, I used a singleton, and we have two possibilities. We could use database builder or in-memory database. The difference between these two static methods is the fact that in-memory database will not persist the data. So if we will add some data or update it or delete it, those changes will not be saved in the database. If we want to persist the data, we should use database builder. Other than that, we need to specify the name of the class that is annotated with the database annotation, the name of the file, and that's it. If you take a closer look, you will see that this builder looks similar with the retrofit one, if you have used it until now. Relations. SQLite is a relational database, so it needs to understand the relations between the entities. But why I use the quotes for the word relations? Since we are using this relational database, SQLite, from an object-oriented language, Java or Kotlin, for sure you have read something about object relational impedance mismatch. This is a fancy way of saying, yeah, it's difficult getting stuff into and out of the database. And usually the purpose of an ORM is to solve this issue, or at least to make it easier. Room also tries to solve this issue and to help us with the translations from the database tables and the Java or Kotlin classes. But let's see why Google decided not to have entities inside of another entities. Okay, let's say that we have our company, and inside of it, I would like to add a reference to the CEO of the company. So I will add this employee with the special rights inside of it. After that, I get all the data from the table, and I display it using a recycle view. So I'll have a list with all the names of the companies. After a period of time, we get a new task that we should display also the name of the CEO for each company. It looks like a simple task. We add a new text view, which set the text company.getDirector.getName, and it should work. I'm done with the task. But do you think it's a good approach, this one? Right now, we are trying to run a database operation on the main thread. So this is why Google decided not to have entities inside of another entities. Because the main thread has only 60 milliseconds, and in order to render the UI and everything else that should be done at that moment. And for sure, even if our query is very, very fast, it's not a good idea to do it on the main thread. Okay, but how we will handle the relations between the entities? Because I just mentioned that we have relationships between the entities. There are 3 different approaches. And I will try to explain you exactly how they work. Let's go back to the example with the company. Our company has 2 different offices, one in San Francisco and the other one here in Krakow. The one from here is the headquarters. And I would like to save these 2 locations, these 2 offices inside of the company table. So I will define this location class with these 2 fields, latitude and longitude. And after that, I would like to save them in the database. In order to do that, we will have nested objects. And the way to list them inside of the entity is by using the embedded annotation. So right now, we will try to add those 2 offices inside of the company entity. Until now, it looks okay, but we have an issue because Room will try to create 2 columns with the same name. Because we'll go back to the location definition and we'll find latitude and longitude. So we'll try to create 2 columns for latitude and 2 columns for longitude. In order to solve the issue, we should use a prefix. And we will add the prefix for the headquarters location. And this will solve the issue, and the structure of the table will be the one displayed right now. Okay, so this was the first one, embedded. Let's say that also the company has some employees. So our company has many employees. Sounds like an usual foreign key scenario. One-to-many relation. The primary key of the company will be the foreign key of the employee table. And Room also offers support for foreign key. And in order to do that, we just need to annotate the employee entity with a foreign key annotation. We need to specify the parent entity, the parent column, and the child columns. And the third approach is by using the relation annotation. Our company has departments, and I would like to get all the departments from the company. But I don't want to connect them using a foreign key. The solution is to create a POJO, and inside of this POJO, we'll embed the company entity, and also we'll get the list of the departments by using this relation annotation. An important thing to mention here is that the relation annotation should be used only for a field that is a list or a set. In order to get the data, we'll create a DAO that will query the database, and we will get the information from there. Queries. We have 4 different types. We have insert, update, delete, and query. Insert, update, and delete work similar. So in this case, they could be applied to an object, or they could be applied to a list of objects, or to a varargs of objects. In these examples, all of the methods have as a return time void, but they could also return an integer. And for the insert, that integer will represent actually the ID of the new inserted row in the table. And for update and delete, that integer will represent actually the number of the rows affected. Query. Query could be used with insert, update, delete, and select. The first example, it's a simple one, but an interesting fact related to the query is that we have observable queries. Room offers support for Eric's Java and also for live data. So these observable queries help us to update the UI. So when something is changed in the database, the UI also will be notified about those changes by using this flowable or live data. Other than that, if we don't know from the beginning what we want to query from the database, and we build dynamically that query, we could use raw query. And this raw query could be also combined with the live data. But in order to get the updates from the entities that we are interested in, we should add in this annotation the observed entities. We should define them. Like I already mentioned, if we will try to run database operations on the main thread, we will get an illegal state exception. Transaction. There are some scenarios when we want to run many operations in the same block. And for this kind of scenarios, using a transaction annotation, it's a good approach. In this example, we insert a department, and after that, we delete an oldest one. So these two operations will be run in the same block. Transaction could be also used with a query, and there are two main cases when it could be used. The first one is when we have a big amount of data, and we are not sure that this data will fit the cursor window size, which is about 2 mega. And the second one is when we use the POJO with the relation annotation. Because in that moment, Room will try to query separately the field, and we are not, in order to have consistent data, we should use the transaction annotation. Threads in Room. If we are using Room 1.0 and we are having two different threads, one that will write something and the other one that will try to read, in Room 1.0, these two operations will be done one after the other one. So first of all, we will write the data, the second thread will wait, and after the first operation was done, the read operation will start. This was in Room 1.0. It's not such a nice behavior, so let's see what's happening in the current version. In the current version, in the case when we have two threads with two different operations, those operations will be done at the same time. Migration. Migration is a sensitive topic, and Room offers support for migration. Our company table in the version number 1 of the database has this structure. After a period of time, we want to make a new release on the market, so we want to add a ref number column in our table. So right now, the current version of the database is 2. So migration actually represents the actions we made in order to migrate the data from a version of the database to another one. In our case, from version 1 to version 2. By using the SQLite open helper, it is necessary to override the onUpgrade method. And this method has 3 parameters. It has the database, the old version, and the new version. This is the classical approach. But we're trying to use Room, so let's say how we could handle it. In Room, there is an object called migration. And in order to provide the migration, we need to override a method called migrate. And this is the Room approach. For our case, we just need to alter the table by adding a new column of type text. And inside of the migration constructor, we should specify the oldest version and the newest one of the database. To apply the migration inside of the database, we should use the add migrations static method. And in this case, we have only one migration, but if we have many, we should add them using a comma. What happens behind the scenes? Behind the scenes, there is a Room master table. And inside of this Room master table, there is an identity hash. Each time when change is added in the database schema, this identity hash is changed. So based on that, Room knows that something was changed in the database. So if you will go to try to see how the tables are looking, you will find that table and also the identity hash. Another helpful thing is that we are able to export a JSON file in our project structure. And this JSON file is very helpful because it contains all the versions of the database. It's helpful for us, the developers, because you are able to see what happened before, and it's also used for testing the migration support. In order to do this export, we just need to use the annotation processor option, and we will get it in the project structure. If Room identifies the fact that a migration should be provided, and we didn't do that, we will get an illegal state exception. In the case when we are not interested to persist the data of the user between the versions of the database, we could use fallback to destructive migration. This method actually will clear all the data of the user from a version to another one, and we'll just update the database schema to the latest one. There are some cases when we have different database versions from 1 to 7, let's say, and I would like to keep the data only for the migrations from version 1 to version 4. And for the other ones, I'm not interested to keep the data, I just want to update the database schema to the latest one. To achieve this scenario, we could use fallback to destructive migrations from, and inside of it, we could specify the versions on which we would like to apply this behavior. Okay, so what are the main Room advantages? We have less boilerplate code. We have SQL queries checked at compile time. We don't have database operations on the main thread. We have maintainable code, and also we have migration support. My presentation purpose was to show you how you can handle an SQLite database in Android development by using this ORM from Google. But if your current solution is fine and it works and you are happy with it, you could carry on. But if you want to try something new and see what options are right now, you could try it. If you have questions, thank you. Any questions?
Hi. What will happen when our customer will miss release in store? And for example, he has a database in version 1.
Yes.
He updates the app, and then he has the database in version 3.
Okay. And he missed the version 2.
Yes.
This is what we are trying to say?
Yes. And we have implemented migration from 1 to 2 and from 2 to 3. Yes.
In this case, it's very helpful that you provide those migrations. And usually Room, when it finds out that there are many migrations, will try to get the path that is the shortest one in order to migrate the data from the current version of the database in the app and to the version from the markets. So in your case, it's helpful to have also migration from 1 to 3. And in that case, Room will get directly the shortest path from your migrations.
Okay, thank you.
Thank you too. Any other question? Yes, please. There is a question here.
Hi. There is a possibility to using join in Room database?
Yes.
Left joins?
Yes, exactly what's possible in SQLite. It's possible also in Room. So you write the inner join or left join inside of the query, and you are able to join many tables.
Cool. Thank you.
Thank you too. Any other questions? Okay then. Thank you for coming and have a nice day. Thank you.